Hi everyone. In this lesson we're going to learn about the properties of rectangles and squares, and then we're going to use those properties to solve problems. I'm going to start by naming the figures that I have here, because it is very important that we know how to name the figures correctly. When we name any figure, we have to start by selecting one vertex, let's say this one, and then we should go in order, either in the clockwise direction or counterclockwise direction, but we have to go in order without skipping any vertex. For example, we could say A, B, C, D, or we could say A, B, C, D, but we cannot say A, B, C, D. That would be incorrect. And naming the figures correctly would be important when you have an exercise without a diagram, and then you need to draw the diagram in order to solve the problem. So I'm going to name this one A, B, C, D, and then the other one I'm going to name P, Q, R, S. Now I'm going to start with the rectangle. A rectangle is a parallelogram with a right angle. So by definition, a rectangle is a parallelogram with a special characteristic that it has a right angle. So for example, angle A is a right angle. I apologize for this because for some reason my pen doesn't want to write. Let me try one more time. I hope it works. Seems like it's working now, but not looking good. So one more time. Okay, so now it looks better. So we have a figure which we know is a parallelogram with one right angle. So because it is a parallelogram, we know that angle C should also be a right angle, because in parallelograms the opposite angles are congruent. So that makes angle C also a right angle. And then we also know that in a parallelogram, any pair of consecutive angles such as A and D, or A and B, or B and C, or D and C, any pair of consecutive angles are supplementary. So that makes angle D, for example, also a right angle, because that's the only way to have A plus D equal to 180, because that is what supplementary means. It means that they add to 180. So angle D is also a right angle. And for the same reason, angle B would be also a right angle. And so that is how we end up with this special characteristic about rectangles, that actually all the four angles are right angles. And not only one, as the definition says. Because we're applying the properties of the parallelogram, we end up with all the angles being right angles. And then we look at the properties. A rectangle has all the properties of the parallelogram because it is a parallelogram. So what are the properties of the parallelogram? These are the properties. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Any two consecutive angles are supplementary. And diagonals bisect each other. Those are the properties of the parallelogram. And then it has one more special property that is for rectangles only. Diagonals are congruent. So if I were to draw DB and AC, would be congruent, And I'm going to try to do that because my computer is not working correctly today. So I'm going to draw diagonal DB and diagonal AC. Okay, so if AC is 10 centimeters, for example, then BD will also have to be 10 centimeters because the diagonals on a rectangle must be congruent. And then because it is a parallelogram, we will actually know that each of these four pieces, or all these four pieces, would be congruent to each other because we know that in a parallelogram, the diagonals bisect each other. So this will have to be 5, 5, 5, 5 centimeters each one. So that's something special about the rectangle. The diagonals being congruent makes each of these four little pieces congruent. In the square now, the square is a rectangle with two congruent consecutive sides. So I square is a rectangle, and this property of having two congruent consecutive sides is a property for the rhombus. Therefore, a square is both a rectangle and a rhombus at the same time. Rhombus. Okay, so a square is a rectangle and a rhombus at the same time. The properties, a square has all the properties of the parallelogram because a rectangle and a rhombus are parallelograms, so the square will have all the properties of the parallelogram, which we already reviewed with the rectangle. And it also has all the properties of a rectangle because a square is a rectangle. And then it also has all the properties of a rhombus because a square is also a rhombus. So the properties of the rhombus, just in case you forgot, the special properties that are only for the rhombus and therefore for the square is that the diagonals intersect at right angles. The diagonals are perpendicular to each other. So if I were to draw them here, such as Q. Okay, I'm gonna leave it like that because it doesn't want to draw it exactly as it should be. And then PR. So these angles would be right angles because that's a property that's coming from the rhombus. The diagonals are perpendicular to each other. And also, the special property for the rhombus is that the diagonals bisect the angles. So, for example, this angle here would be equal to this angle here. And since this is a square and a square is a rectangle, the angles would be right angles. And so these little angles here would be 45 and 45 degrees. So with that, we go to number 1. Exercise number 1 says quadrilateral RSTU is a rectangle. If RS is equal to 3x plus 8 and SC is equal to 6x minus 28, find RT. So we're given RZ, I think I say RS. If RZ is equal to 3x plus 8 and SZ is equal to 6x minus 28, we have to find RT. So we're given this piece here, and this piece here. And because it is a rectangle, we saw above here that these four pieces would be all congruent to each other. So we can actually use that fact to set up our equation and solve the problem. So in this case, this piece is equal to this piece, and those are the two pieces that we have. Therefore, SZ is equal to RZ, which makes 6x minus 28 equal to 3x plus 8. Putting all the variables on one side, we have 3x. Putting all the numbers on the other side, we have 36. So x is equal to 12. And now we can use the value of x to find RT. RT is the entire diagonal. And we know that this piece TZ should also be congruent to RZ. So this is also congruent to the other two. And RZ is 3x plus 8. That will be 3 times 12, 36. 36 plus 8, that will be 44. So if we have 44 units here, this piece would also be 44 units, and therefore we can find that RT is equal to 88 units, whatever the units are. We're not using any specific units such as centimeters or inches or feet, but those would be the type of units that we should be using here. We're just not using them. So number 2, in quadrilateral RSTU, quadrilateral RSTU is a rectangle. If the measure of angle UTR is x plus 9 and the measure of angle RTS is 2x minus 3, find the measure of angle UTR. So angle UTR is this little angle here, and that measurement is x plus 9 degrees. And the other angle is angle RTS, and the measurement for that angle is 2x minus 3 degrees. So we know that this is also a rectangle, and we know that rectangles have right angles. We're working with this angle over here. These two angles, these two pieces make up the big angle at T, which is angle UTS, and we know that this angle is a right angle. So the measurements of these two are equal to 90 degrees. The sum of these two measurements are equal to 90 degrees. So this would be the measure of angle UTR plus the measure of angle RTS is equal to 90 degrees, and that will make x plus 9 plus 2x minus 3 is equal to 90 degrees. Simplifying the left side, we would have 3x plus 6 equal to 90 degrees. Putting all the numbers to one side would be 3x is equal to 84. And that will make x is equal to 28. So now we have the value of x, and with that we can find the measure of angle UTR, which is the little angle here, whose measurement is x plus 9. So the measure of angle UTR is equal to 28 plus 9, which is 37 degrees. And we go now to number 3. And number 3 says quadrilateral ABCD is a square. Find the length of AB. That's part A. And part B, find the measure of angle 1, the measure of angle 2, and the measure of angle 3. So for part A, in order to find the measure of side AB, we can use an equation using any two of these 3 sides whose measurements are given to us, because we know that this figure is it's a square. And in a square, all the sides would be equal, because a square is also a rhombus, and in a rhombus, all the sides are equal. So we can actually use any of these 2 sides. I'm going to be using DC equal to BC. DC equal to BC. That makes 5V plus 1 equal to 3V plus 5. Putting all the variables on one side, that will be 2V and all the numbers on the other side will be 4, and B is equal to 2. And then in order to find the length of AB, I can use also any of these measurements because all the 4 sides are equal. So I'm going to use DC, let's say. So we know that AB is equal to DC, and therefore AB would be equal to 5 times the value of B, which is 2 plus 1, and that's equal to 11 units. And now we need to find the measures of angle 1, 2, and 3. So because this is a square, and a square is a rhombus, we know that the diagonals bisect the angles. So angle 1 and angle 2 must be congruent because diagonal BD bisects angle ABC. And because this is a square, and a square is a rectangle, we know that all the 4 angles here are right angles. So this one is also a right angle. And that makes angle 1 and angle 2, both of them 45 degrees in order to form the right angle if BD is bisecting angle ABC. So that makes the measure of angle 1 equal to 45 degrees, and the measure of angle 2 also equal to 45 degrees, and the measure of angle 3 would be 90 degrees because a square is also a rhombus, and in a rhombus the diagonals are perpendicular to each other. So we have right angles here, especially angle 3, which is the angle that we want. So the measure of angle 3 is 90 degrees. And that will be it for today on how do we use the properties of rectangles and squares to solve problems. As always, check the website, the class website, in order to see what is the homework.